Study guide for Chapter 9, Geometry Test. Name a circle. A circle is the set of all points in a plane, a given distance from a given point in that plane. The given point is called the center. The given distance is called the radius. You name a circle by its center, so we would call that circle E. Its center is the point that all of the points on the circle are equidistant from. It is that given point, point E. The given distance is the radius, or we could say the radius is a segment from the center to a point on the circle, or we could say that the radius is half the distance across the circle. So we have two radii, segment EA and segment EF. Three chords. A chord is a segment that joins 2 points on a circle. GH is a chord. AC is a chord. AD, excuse me. But then that red one, AE, all the way from A to E, is also a chord because it joins 2 points on a circle. Excuse me, AF. But AF is a special type of chord. AF is a chord that passes through the center. It represents the full distance across the circle, and we call that a diameter. A diameter is a chord that passes through the center of a circle. A diameter is the distance across a circle. A secant, the way I remember it, it goes through the C and can't stop. GH is a chord that joined 2 points on the circle. It didn't go all the way through. The one that goes all the way through would be from A to C. You can see I'm getting off as I go through there. We normally name a secant as a line, but we know in this chapter we learned if two secants are drawn to a circle from a point outside, then one whole secant times its external segment. So we were talking about a secant as a segment. So we could call the secant AC. We couldn't say AD because AD is a chord. To make it a secant, we had to go past the circle, see. A tangent is a line that lies in the plane of a circle. It intersects a circle in one point. Now, we've talked about that segment, a segment as being a tangent also. Line BC would be a tangent line. We could say that segment BC is tangent. The point that tangent line intersects the circle at is called the point of tangency. So point B would be a point of tangency. Any questions on the first date? Okay. So a circle is a set of all points, a given distance from a given point. The given point is called the center. The given distance is called the radius. A chord is a segment that joins 2 points on a circle. A diameter is a chord that passes through the center. A secant is a line that lies in the plane of a circle and intersects a circle in 2 points. A tangent is a line that intersects a circle in 1 point. I said that kind of backwards. Let me back up. A secant is a line that intersects a segment. A secant is a line that intersects a circle in 2 points. A tangent is a line that lies in the plane of a circle and intersects the circle in 1 point. If it intersects a circle in 2 points like a secant, it's automatically going to lie in the plane of it. And then the point of tangency is the point where the tangent line intersects a circle. Common internal and external tangent lines. A common tangent line is a line that intersects two coplanar circles. It is said to be internally tangent if it passes through the segment that joins the centers. It is said to be externally tangent if it does not pass through the segment that joins the centers. So we want to identify what we call the segment of centers. We want internal tangent lines, so that would be a line tangent to two circles, two coplanar circles, that passes through the segment of centers, that does that. And so segment BG or line BG would be a common internal tangent line. Line FC is tangent to two coplanar circles. It passes through the segment of centers. So line FC is also a common internal tangent line. Line AD is tangent to two coplanar circles. It does not pass through the segment that joins the centers, so it is called a common external tangent line. Line EH is a line that is coplanar, that is tangent to two coplanar circles. It does not pass through the segment of centers, therefore it is a common external tangent line. In the next picture, we will begin by identifying the segment of centers. Line IJ, or line, JM is tangent to those two circles at that point. It does pass through the segment of centers, so line JM is a common internal tangent line. Line IK, is tangent to those two circles at those 2 points. It does not pass through the segment that joins the centers, so line IK is a common external tangent line. Line NL is coplanar, is tangent to two coplanar circles. It does not pass through the segment of centers, therefore it is a common external tangent line. The next picture, we draw the segment that joins the centers. This thing right here, QR, passes through the segment that joins the centers, but it's not a tangent to either circle. It passes through the little circle in 2 points, so it's a secant to it. It also passes through the big circle in 2 points. It is a secant to it, so it's nothing. There's not a line that passes through the segment of centers that is tangent to the two circles, and so there is no common internal tangent line. ST is tangent only to the big circle. It is not a common tangent because it's tangent to only one. PO is tangent to the big circle at O and the little circle at O, so PO is a common tangent line. It does not pass through the segment that joins the centers, and so line PO is a common external tangent line. So a common tangent line is a line that is tangent to two coplanar circles. It is said to be internally tangent if it passes through the segment of centers. It is said to be externally tangent if it does not pass through the segment of centers. Number 15 says name a pair of internally tangent circles. Tangent circles are circles that are tangent to the same line at the same point. Coplanar circles, they have to be coplanar. Coplanar circles that are tangent to the same line at the same point. Well, if we look at the second picture, circle, the two circles there, the big circle and the little circle, are both tangent to the blue line at the point in the middle. So those are tangent circles. One is not inside the other, so we say that they are externally tangent because they're outside each other. So those two circles in that picture would be externally tangent. Now, on the transparency, there weren't centers marked, but in the student edition and teacher's edition there are. And so circle W and circle X would be externally tangent circles. On the last picture, the little circle and big circle are both tangent to the red line at point O. Since they're two coplanar circles that are tangent to the same line at the same point, we say that they are tangent circles. One is inside of the other one, so we say that those are internally tangent circles. This point is Y and this point is Z, so we can say that circle Y and circle Z are internally tangent circles. Any questions on that? So tangent circles are coplanar circles that are tangent to the same line at the same point. If one is inside the other, we say that they are internally tangent circles. If they're outside of each other, we say they're externally tangent circles. Okay? Name two minor arcs, two major arcs, and a semicircle. An arc is a part of a circle. A circle is the set of all points in a plane, a given distance from a given point in that plane. So an arc would be a part of the points in a plane, a given distance from a given point in that plane. See, it's a part of a circle. Now, a minor arc is between 0 and 180 degrees. So it's less than a semicircle. And so if we saw a diameter, there's a diameter at XA. There's a diameter at XA. So if you want to find a minor arc, you start at one end point of the diameter and you go less than all the way around to it. So if we started at X and went to Y, I'm having trouble getting this to do what I want it to. But anyway, from X to Y would be a minor arc. From A to Y is less than a semicircle, so AY is a minor arc. Remember that we name a minor arc with two letters. Now, if you want to find a major arc, then you can use your minor arc and go the long way around. If I go the long way around from X to Y, I would have XAY. That's a major arc, more than a semicircle. If from Y to A, the short way around is a minor arc, then from A to Y, Y to A, the long way around is a major arc. So a major arc would be AXY. We name the major arc with three letters and the minor arc with two letters. It says name a semicircle. A semicircle is formed when a diameter is drawn. the endpoints, if you will, are going to be X and A, which are the endpoints of the diameter. We can go the top way, and we would have XYA, and we could go the bottom way. So there's two semicircles. So you can't just call a semicircle XA because there's two semicircles from X to A. So we have to use three letters. If we go the top way, we would have XYA. If we go the bottom way, there's not another letter in there, so we cannot name the bottom semicircle because we would have to have three letters to name it. Okay? Okay, number 20 through 24 say find the missing links or angle measures. Find the missing links or angle measures. I'm going to wipe this out just to have some room to focus on that problem only. So what we have, this is the center. AY is a radius. AB is a tangent. So we have a radius drawn to a tangent line, a radius drawn to a point of tangency is perpendicular to the tangent line at the point of tangency. So angle XAB is 90 degrees. Any questions on that? It then says if XY, this little piece is 4, and YB, this little piece is 25, then find AY. I'm going to call it little a for altitude. Do you see what we've got here? The whole big triangle is a right triangle. AY is the altitude drawn to the hypotenuse. This is chapter 8 stuff. If the altitude is drawn to the hypotenuse, then the altitude is the geometric mean between the two segments of the hypotenuse, and either leg is a geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. Geometric mean, you can set up a proportion, or you can just cut through all that and go straight to saying that the geometric mean, that to find the geometric mean, you multiply and take the square root. So we made circles and we made the little lines on that, remember? So the altitude A is the geometric mean between the two pieces of the hypotenuse, 4 and 5. Therefore, the altitude A is the square root of 4 times 5, square root of piece times piece. So A is the square root of 100, and so A is equal to 10. So the altitude AY is 10. Any questions on 20 and 21? Okay. Number 22, we have a radius drawn to a tangent, so it's perpendicular. We have a radius drawn to a tangent, so it's perpendicular. A radius drawn to a point of tangency is perpendicular to the tangent line at the point of tangency. So angle EFI is 90 degrees, as will be the angle at I. We know that the angles at G are vertical, and vertical angles are equal. So we have two angles of one triangle equal two angles of another. Therefore, the triangles are similar by angle-angle similarity. If we want to name that similarity, the G's were the verticals, so they both go last. F was 90, I is 90, so I goes in the middle. And the only thing left is H, so H must go first, so we name the similarity. If they're similar, that means they're the same shape, which means that corresponding angles are equal. and corresponding sides are in proportion. So we can find a missing side by using a proportion. So we're going to say 4 is to 3 as 5 is to GI, and get a proportion. You may say, well, how did you know that the 4 went with the 3 and the 5 went with the GI? Well, if we just look at how they're named similar, EF, first two letters, goes to HI, first two letters. EF, first two letters, 4, go to HI, first two letters, 4. So there's your 4 and 3. We're looking for GI, that's the last two letters. So we would go with the last two letters, FG. So IG goes to FG. There's FG. There's IG. So 4 is to 3 as 5 is to IG. To solve, we cross multiply. We get 4GI is equal to 15. We're going to undo multiplication by division. And we're going to get GI equal 15 fourths, which we can leave as that. Make it a decimal, 3.75. Make it a mixed numeral, 15 divide 4, 3, 12, 3 left over. Put the remainder 3 over the divisor 4. So 15 fourths, 3 and 3 fourths, 3.75, any of those, that's a 3. Any of those are okay. Any questions on the first 24? Okay. We're going to stop there, and then I'll record the rest in the second part.